So welcome to today's session. Today we are going to have a hopefully insightful session that is going to be led by Victor Ashioya, and the session is going to be on CICD fundamentals. So we are going to learn a lot about that. Victor is a machine learning engineer, and we look forward to learn from him. So the quote of the week is, "If you risk nothing, then you risk everything." So if you do not wish to take a risk or to take a step into trying out something because you feel maybe you will lose, when you don't take that step is when you lose. So that is the quote of the week. And then on our agenda today, we are going to have, we're going to have an icebreaker. And then after that, I'm going to share with you the meeting expectations. And then we are going to learn about the community. And then after that, we are going to go into the session, which is CICD fundamental. So for the icebreaker, we have a simple question here. When and where? So this was supposed to be when and where did the DevOps concept start? So you can respond on the chat. So when and where did the DevOps concept start? You can just respond on the chat. You can't hear any sound? I can see Victor, am I audible?
Yeah, you are. You're audible.
Okay. So probably Obiauzu, you need to check your probably a headset or something. Oh, that is good. So when and where did the DevOps concept start? You guys can reply on the chat. You should be able to chat. So Winnie says 207, where? Anybody else? You guys can type on the chat. Don't fear anything. Feel free to type on the chat. You can just try. You don't have to be correct, actually. You can just, even if you're thinking about the date, you can also Google. You're allowed to Google. Any responses? Any more responses from you guys? So Felix says in 2009, the first conference named DevOps Days was held in Ghent, Belgium. Okay, thank you, Felix. Is there anyone else? Maybe you can get like two more. Okay. So it seems people don't like chatting. Probably you like talking, and I've muted everyone. So actually, so DevOps, the discussions about DevOps started in 2007, but when the term DevOps was coined this in 2009, and we had the first DevOps Days session in conference in Ghent, Belgium, and it was started by Patrick Debois or Patrick Debois. So that is something you should know, especially if you're a DevOps engineer. So can move on. So for our in-house rules, you're expected to mute yourself. Of course, I've already muted you. And then you're expected to raise your hand if you want to speak. You can use the chat box to write your comments and questions. You're also expected to be respectful and curious. So be curious, ask questions, and we really encourage you to type, to ask questions, to be interactive, so that the session can be interesting. So yeah, and then now I'll be sharing about the community, and we're just a community of DevOps enthusiasts We have people in our community who are experts, and we also have people who are new to DevOps who are here to learn. So we our mission is to create a supportive and inclusive community that values diversity and supports learning and growth. Our vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their career. So we are basically a community that provides the environment for people to learn, for people to network, and for people to grow in their careers. So if you are joining us for the first time, you are in the right place. So here is part of our team. We have around 25 community managers who ensure that we are able to run our events successfully. And then, in case you want to help, some of the ways in which you can help is by volunteering to help or even running sessions or helping us in following up with speakers so that they can be able to have an easy time while they're preparing to run the session. And then you can also connect us to other people who you think can add value to the community. You can give us feedback, and this feedback can both be uh, positive feedback or constructive feedback. You can share with us ideas that we can use to make the community better. You can share what your experience, your expertise. You can share your knowledge in our channels, in our online social media. You can also share our posts when we post them, so that we can be able to reach out to more people who may be interested in DevOps. So also, in case you're talented in documenting activities, you can join us and help us maybe with photography, videography, and such things. Even in content writing, if you think you can do that, you can help us. You can join us. So we are creating a blog. So if you think you are talented in that, you can join us and you can be writing the blog for the community. So you can also help us in organizing events. So we have a number of events that we do. So we have online events like this one. We have physical events that we do. These are physical events that are normally workshops. We also invite speakers and the opportunities for people to network and learn. We do them in partnership with Moringa. And we also have other physical events like the one we had last week at the data center, Africa Data Center, which was geared towards just exposing people to what data centers look like and also providing an opportunity for people to network. So in case you are not part of the community yet, in case you've not joined, you can scan the codes, the QR codes, and you'll be able to join the community. So you can scan the LinkedIn, WhatsApp, and Twitter. Those are the active ones. And there you'll find people, uh, especially on WhatsApp. It's a good place to be, where you can see what people are posting. And for LinkedIn and Twitter, you can post on LinkedIn as well, and you can see our updates. Same to Twitter. So now we go into the session that is CICD fundamentals, and our speaker for the day is Victor Ashioya. So Victor, if you don't mind, you can share your screen, then you can proceed. So I'll stop presenting. So hello, Victor.
Hello, Samuel. Hello, everyone.
Okay.
Yeah, so I'm Victor Shares, and Samuel has introduced me. I'm a machine learning engineer. Yeah, so we'll get right away to the session, and we'll start off. We'll just look at our agenda for tonight. We'll just dive into the basics. ACD was the basics, the definition. Yes, this is just the definition, the workflow, the benefits, the tools, then the best practices. Then we'll just have a quick look through to a demo here we have. Then we can have the questions. Yeah, that's it for the agenda. So we'll start off right away to what is CICD. So yeah, so CICD is two terms, right? And before I begin, there's something I always like saying, like when I'm interacting with DevOps or just working with the CICD, I think of it as a pipeline, right? It's a pipeline. So in think an analogy, a proper analogy is a pipeline. Think of it like a pipeline integrating you from, it could be a data, it could be a data source to the user, or data source to an app. Okay, so it's a pipeline. Think of it as a pipeline to understand it well, proper analogy. So the first part, CI, is the practice of frequently merging code changes into a shared repository and automatically building and testing each change. Enables rapid feedback. Okay, so okay, that's just a highlight of the advantage. So it's a, so you can think, so when you are writing code, every time you have you work in big, you work in a big corporation, you work with different teams. It's not, it won't always be something like you're all alone, so you can push any change you want. Okay, you, all things are documented. It's a big organization, so everything you merge code changes, you commit up, you push to the repository. This is tested in everyone, so everyone has to see, right? Now that practice itself is the continuous integration. We will go down to it into the tools, but just let me show you. Let me show you. Think. Wait. Let me show you when you have GitHub. Let me just show you GitHub how it is. GitHub actually nowadays. In the past, it used to be a different thing, but it used to be a difficult thing. That is, but nowadays I can see it's easier. So let me share this and show you just somewhere you can do integration real quick here. Okay, so GitHub nowadays has this. So actually, when you start pushing code, you'll notice they are suggesting for you workflows, then suggesting for you the tools here. Okay, so they'll suggest to you the Jenkins, they'll suggest to you the Travis. We'll just look at them, but I'm just highlighting. But you'll see them here. Okay, yeah, those are the basics of the CI/CD. So you can think of CI/CD from the base, from the margin itself, the code itself. Now, so what is continuous delivery now, which is CD? It's building on CI, which is continuous integration, by automatic delivery of code changes to testing and the production environments. I've seen several places. I've seen several areas which is actually called continuous deployment. Okay, so I've seen people use continuous delivery, continuous deployment, but I think I'm stuck with continuous delivery because that's when the first time I started learning about DevOps, from a machine learning perspective. The instructor, the person who was teaching me, so told me it is continuous delivery, so it's stuck. But so many people I know, they call it mm, continuous deployment. It's okay either way, but you can just know it. You just know that it builds on the automatic, on the CI integration. Now the code changes, the merge code, the code merging itself. It builds on top of it now to ensure the continuous the automation itself. All right. Now this is where you write scripts. You have the Kubernetes. You have the Docker engine setup. Okay. We'll just look at that further. All right. Now, the goals of CICD, you'll find deeper goals, but I like to think of these three because the many times I've used this is the main focus I see. Like, and the many software engineering teams I've interacted with, they'll tell you this, especially number two, they'll tell you improved software quality. That's it. No, it's not you alone, you're working on the code, so it's everyone has eyes on the code. So if you push something, they say, oh, Victor pushed this. So let's see which code is this. He hasn't highlighted, he hasn't used proper comments. Okay, if it's Python, he doesn't. If it's React, the code looks ugly. The comment, so it acts. The quality hasn't looked well. So it will improve software quality. You interact with teams. Not many people understand the way you code, so there are many people, but so you have a standard way. Okay, then there's faster release cycles. Of course, now you have from version 1 to version 1.5, for example, you can have faster because now you have an automation cycle. You have a routine checkups with the merge codes, with the commits. Okay, then we have number 3, enhanced ability to innovate and iterate. Now, this is from a perspective of continuous from the meetups. Okay, now the dev stand-ups in an organization where you just eh, you and and the entire software engineering team, for instance, you look at the code, you study what from the previous cycle and what the community or the users have said, have given the feedback, that is, and then you learn from it, then you continue building on it. So those are the three goals I personally like to use, and I feel like there's a very common goals. There are way when you use when you go to this plural site Andela, they will give you like 10, but I like to look at this from this because they cover the broad aspect of it. All right. Now we go to the key principles of CICD. Now drawing from. Now you'll notice just to look at compare the two, but you'll notice the goals and the key principle. The key principles come from the goals. Okay, just building up. Now there's frequent code commits and merges to shared repository. Of course, now you are working with teams, as I mentioned. It's a continuous integration. The frequent code commits and merges to shared repository, that's it. That's one of the principle of it. Now that's one of the backbone. Okay. Then you have fast feedback loops. Of course, you have your manager or a junior developer, you and the teams. You can feedback in real time. You can tell someone from team A if someone was building on the interface and the other person was building on the back end. You can interact and say, "Hey, I didn't like the UX. I really didn't like it. Can we meet up later? Or can we strategize later on how to build this or how to automate this, do that?" Then we have shift left and testing. Shift left is testing early in development life cycle. So this is the part basically past prototypes, and then the past basically just past prototype. Okay, so the earlier the development cycle you have, it's internal now. That's the internal part. Your software engineering manager and people in higher ups, a few people, and maybe it's one or two junior devs. You just look at it, then you say, "What do you think?" Yeah, it's usually if you've interacted those meetings, usually just a whiteboard. Then they come with the app itself, the prototype is drawn there. Then you have a presentation on the phone, or it could be a web app. Then you should just show the team like, what do you think of this? Is it how can we proceed from here? Can we say this is a proper foundation? Yeah, that's shift left. Think of it in that analogy. Then automate repetitive processes. Yes, the automation part is really useful, especially if you write scripts, bash scripts, Python script. It's really useful. So that's one key principle. So you don't have every time to write a certain script. Why don't you just automate Docker and Jenkins and Travis CI and say, this script every time I just have to change maybe a certain line. Maybe after a certain test, I have to change a certain, but it's automated script, right? Now that way you reduce the workload. You use what's it called when your brain when you work a lot on your brain, you feel like, yeah, the workload on your brain, that is, then you save on time. Now you have time to focus on the bigger things, on the bigger aspect. Then there is incremental code changes and releases. Of course, now this is the building up part of it. So the version 1, version 1.5, what did the community say, what the user saying? Then you come back, the cycle continues. So it's just a cycle. The CICD, you can notice it's a cycle. It's just a continuous cycle. And then from the logo, you can see, the DevOps itself, DevOps in general, you can see from Nairobi DevOps community. It's a cycle. Okay? So, the origins of CICD. Okay, that's now the background. As we mentioned, of course, that was 2007. But what prompted CICD? It was the extreme programming 90s. Microsoft, I believe, companies like Oracle, this big tech. Uh, the teams there want to actually, there's this I think there's this Microsoft, one of the execs, those are Microsoft Dev Day around 90s, mentioned something about CICD. So the one of the earliest things. So this extreme programming, this having code bases, you have code base A, code base B, code base, you have code bases everywhere. It was one of the things that actually prompted to, then we came to agile software development, popularized CI/CD, then we enabled rapid iterations. But for the sake of knowledge, since we all know, it's actually what Samuel said. It's in 2007. But these are the origins, like what prompted, why do we need DevOps? Why do we need the CICD, this aspect of DevOps, CICD? Then alternative to rank release and testing cycles. Okay, yeah, this period of waiting time between version 1, version 1.5, and the cycles. Those are the things that these developers were thinking of when they came up with the whole idea of CI/CD pipeline. Now we can start. We can begin. We can begin now into the base itself, the talk itself, the workflow, the CI/CD workflow. So a developer continues to commit code changes to source control, e.g. Git. Okay, there's GitLab, there's Git, but Git is a common one. Then continuous integration server detects changes and kicks off build. We'll see this in a minute. We'll see this in tools, that is. So let me just demonstrate this first part. The developer. Okay, no, we know the version control, so I won't focus. So let's focus on the continuous integration server detects changes and kicks off build. So I have this script. This was a community project, but I have to refresh tokens, and not now. It's a lot of tokens. If I start refreshing right now, I'll come up with a proper build. So not now, but I'll show you what it basically does. The code base is here. You can probably replicate it. I know there are several reasons. The Linux Foundation has a proper layout, by the way. So let me show you first. So this is it. Yeah, this is a script. This is a script that runs. So you can see the last part, it was building, then it passed. You can see, when is it build here? Yeah, it was passing. So I can't run it, but this is the script part of it. Okay, there's this part of it. Now you can see the script part of it here. There's a feed API. There's basically this feed API. It was a backend. Now the user is the it's basically a front end and a back, and then there's an interface in the middle. So I worked here, I worked on the network, the reverse proxy, and a bit of the back end. So this script itself here, once could have come here, and let me share this tab and say, once I could have come here and go to our feed API, right? I come to our feed API service, then set just set anything, like change this port. Even let me just, if I could just come here and change this port to 8081 or 8082, it could trigger an automatic build on our Travis here. Now Travis here is a tool. We'll look at the tools a bit from, but I just wanted you to show. So as you can see here, that was what I was mentioning here. So I can't run these tools right now. I have to set a plan. Cancelled my credit card anyway. Sorry for another. I cancelled it, so because it accrues anyway. When you start working on it, it will accrue. So you accrue tokens. You use tokens now, and the tokens in turn they charge money. So yeah. So in case you're not using it, it's better safe just to close your integration tool for that time. So once this thing, once I refresh, once I say get the tokens right now, then restart this job. I'll build this restart job. Then the code base will start building up from the bottom. It will consider that the period that it was off, it wasn't working. There were changes, that is. So it will just start building. You can notice here. Yeah. Yeah, this was the here. I built it. It ran for 6 minutes. That's the last time. This is job number 16.1. So you see, and it passed. So to tell you if it passed, now this is a beauty. There's another beauty of it. It gives you a log. There's a build history here. Then there's a log of why it failed, and if the build, there's a check. Okay. There's another example. There's another example when you build PR, when you submit, let's say, when you submit the certain PR, they integrate. So I was mentioning GitHub made it easy. So there's a certain PR. I noticed when I was submitting those, I was submitting for a certain conference, machine learning, and I noticed they are building. They're also doing continuous integration on their GitHub. So instead of submitting a paper once, you can actually submit a PDF, and then when you make a change, it is triggered. And when the change doesn't follow the format, it actually it doesn't follow the format, the build fails. The log will show you the build fail, and which is really wonderful, because many conferences have different format. They require the paper to be submitted in different, could be latex, it could be, it's not latex, but it could be different, but there could be certain like different version. So you notice, you previously, commonly when you submit, you just have to submit a document, and then it could lead to a disk rejection. But this, This when I saw this submission, and I saw this is great because now I can write a paper, submit it, and then it fails. I'm checking the logs real time, and I'm checking. It tells me, oh, it was the title that failed. This title is in this format, capital letter, all titles that should be in capital letters, and such a things. But that is an example. As an example, I've seen that, and probably there are a lot. So for me, I come from the ML perspective, but I know in software there's a lot they are building, right? We could start talking about the continuous integration, the small stuff. We could sit here all day. Now that's an example. Now that's an example. Let's go back to our talk. So yeah, now the build stage itself. Now we run automated tests, the unit integration. So you have a code base. I usually interact with software engineering teams. Then they have code base. Then they have to write unit tests. I know unit tests are very important. So in the past, I used to wonder why unit tests really necessary. I grow then I realize wow, they're really important because they help to check your code, like to check every build that's running. So yeah, admired unit tests. So the unit test and the integration are very great. So you have a unit test here in your code base. Then the unit test will be used by say Travis CI to pass the integration test. Okay. So then we have the builds. Part of the builds is the code linting, the syntax checks. I've seen code linting actually in VS Code. I've seen VS Code implement code linting. There are tools in VS Code. So you see, the CI/CD workflow itself is coming down. This is coming narrow. It's being simpler, making it simpler and simpler. I've seen code linting. I know most of us we have actually interacted with code linting on VS Code. And then the compile code. Sorry, the compile code part of it, the compile code, you can compile code in web apps. I know web apps compile. I know if you've used something like say Streamlit, that compiles in real time. Flask, yes, Flask, a great example. Flask compiles in real time. React, yeah, React compiles. There's latex. Now the latex is in when you're creating PDF text files. Those are submission of conferences and stuff. It compiles code. Now that's the build state. Now there's the final part of it's the package application. Now this is the package you come with. You say this is version 1.0. This is version 2. Let's see here. Let's see in our code base where I can show you the code packaging part. So let's see. Yeah. Yes, here it is. Here it is. Okay, it's the part. This is version 1. Luckily for me, it was really nice because version 1 ran. But the other examples which version 1 failed miserably. So I have to iterate again version 2, version 3. So this is you define. You can see this is a dot. It's a YAML file. So it's a what's it called in full name? Uh, anyway, I'll remember. But I like just call it YAML. Anyway, YML file in simple. So it's app version 1, you could version 2. Now this is the packaging itself. I wanted to show example. So you see, you're describing your app here, you're describing the build, you're describing stuff like the CPU usage, the limits here we have, then the environment. For environment here, I use the Postgres, of course, database, such and such. It doesn't matter, it could be different. You can see here, even this Postgres was running on AWS. Okay, so you can see here it was running on AWS, such and such stuff. So let's go back. Then now, okay, it continuous delivery or continuous deployment system takes build artifacts and deploys to environment. Yes, build artifacts are the code base itself. Now, when you write the scripts, those are artifacts. Okay, they become artifacts once you write the code itself. They'll save itself as an artifact in the workflow. There's a workflow document. Let me show you. Let me show you something. So this was a monolith to microservice. So okay, this was it. Yeah, yes. The workflow itself is here. Okay. Yeah, exactly. So this is it. You can see here I even use Jira. Yeah, so it builds artifacts. Now this workflow, it's what we called it's basically, think of it as an environment. If I to use an analogy, it's an environment. Think of it as an analogy. It saves everything, saves the metadata exactly of your code. It doesn't your code exactly, it's a replica of your code. Okay? Yeah, you can see here. It's basically save everything, the repo, the repo itself, the PR number, the repo link. So you can think it's saved it's saving a replica, it's saving it here. So this is an artifact. It's basically your code, but it's a replica of it and deploys it to environments. Our environment here, as you can see, was Jira, but there are a lot of environments you can use. Now the environments, which is, the environments. Now we have the testing and staging. Yeah, you know this part, and the production. Yeah, this part I know you know them. So approval gets before promotion between environments. Yeah, now this is the teamwork part. You and your team have to discuss. Oh, is this staging okay? Is this testing part passed so that we can stage it for production now? Yeah, such and such stuff. Then now we have our illustration of a CI/CD workflow. That's basically, I think, tend to look at this as the most quickest and the quickest way to learn CI/CD, the workflow itself. It's quite easy if you look at it. Now look at this. This is the code. This is the first part of the code, and then block this part, the related code. The related code. Block this part. Assume it's not there first. Then you commit, then it builds, then the unit test. Remember, you wrote the unit test in a script, right? And then you deployed it as part of your code. Then it does the integration test. The integration tests come configured. You configure them, or sometimes they come configured. By default they come, but you can customize them. Then the review part. Now there's the team part. The pipe. Now that's the team part. You have the reviews, the different teams, the review, the workflow, then the staging, then the production. Now come back to the related code. So you have done a version one. The version one, a client says, "Oh, I don't like this interface," or "I don't like this bundle." Yeah, how about we change it? Then, yep. The developer comes says, "Okay, let's change it." You add up the button that you want. Say the CSS files. I know the stuff. I don't know much about CSS in it, but say something like that is needed. You do the change again, then you commit. Now the build continues. So you see how you can see it's actually a beautiful thing. It's automated cycle now. The related code, it's added, it's committed, the build starts. Once you just commit, the build starts. It triggers a build. Okay? This is the Travis CI now part you have. It triggers the build, then we have the unit test starts checking. It starts checking. Now that's the part I was telling you. The build can fail, then you can have the logs checking. Oh, what did I fail? Or something did not run, some such and such stuff. Now that's our basic workflow. Benefits of CI/CD. Benefits are a lot, but I like to minimize them. You can just see there are a lot of benefits. Apart from the automation makes work easy, of course. Now the faster time to market. Now you have reduced the time cycle from commit to deploy. As you have seen from the workflow, we have reduced the time between the workflow and the. So you can see this workflow actually it makes it look very very easier for my CICD. Like when you had multiple code bases which you will come to merge later. You see, you have reduced the time. And everyone has saved there's this thing, the workload on your brain. You don't have to. I don't think a lot every time. Then the increased release frequency. Yes, another thing. So you see, let me use something we know a lot. Which one? Say WhatsApp. WhatsApp. Yes, WhatsApp. You can notice after 2 or 3 weeks there is a release frequency. There's a small change. There was a bug. There was a feature. Why? Because they've interacted with some people and the people gave them feedback. No, I don't like this profile picture button, how it pops up. I don't like how it pops up the screen. Then think of, and then you can see how the dedication they have. So you might wonder something like WhatsApp. I know it's a huge code base. So how are they doing it fast? It's because they're implemented CICD. In fact, WhatsApp implements this whole workflow. It does uses Travis CI, uses Docker. Yeah. So WhatsApp is a great example. I think they do monthly releases. Yeah. Then we have improved productivity. Of course, now you don't have to keep your mind fixated on the same stuff. Now you have productivity. There's a word I'm looking for. Your brain doesn't have to focus on the workload every time. You focus on other stuff. There's a word that can summarize this. Just think of it later. Then you automate manual processes. You can see the scripting part, the unit tests, the integration tests. Those are the scripts, and you have eased the workload. Yeah, you've used wastage time on long integrations. True. Again, the analogy we were using, remember, you have different teams. Now imagine in the previous world, like previous time, that is, the teams didn't have an integration tool. So what you had to do, like you had to come later. So you dedicate a full day, and a literal full day, you merge your code base one by one so that you have a thing. Okay, so the front end team, the back end team meet on a literal full day, 9 to 5, doing that. But instead of but but the goodness of CCD now, that time has been reduced. Now there's no need for long integration. 5 hours, 4 hours. I've interacted with teams that are doing it in 2 hours. I was amazed. I was really amazed. 2 hours. They were building this they were part of this game, I think. Yeah, they were part of this game app. So they were one or two. There were 4 people. So the two were part. The two, okay, not 4. The ones I know, there were 4. They were interacting with teams in Europe, Asia, and all that. So there were 4. But between the story that I know. So we could sometimes stay together, and at 3 a.m. Now 3 a.m. Kenyan time. It could be something like 7 in the morning. It could be something like 9 a.m. depending on where you are. So they could do something from 3 a.m. and around 5 to 6 a.m. in the morning they were done. I used to be really amazed. So I was thinking like maybe they would take the whole day and start integrating, but 2 hours they were done. I'm calling my friend. I'm like, wow, are you done? I'm like, yeah. I check my laptop. It's just building now. In case of any code change, it will just automatic. I used to be really amazed. Really, I'm still amazed by this stuff. Now we have enhanced software quality. Of course, now your code quality is increasing. The software quality by default is increasing too. You're catching issues that are through rapid feedback. Yeah. You have rapid. If it's a commit, if it's a PR, someone will leave a comment right there. You're waking up at 6 a.m. It's in your email. If you are using GitHub for mobile, it's in your mobile app. If you've integrated your phone number too, it's the SMS is there. It's telling you there's a bug. You need to fix it right now. You have reduced bugs and defects, improved reliability, and the cycle continues. And this better collaboration, this shared ownership through version control. You know who pushed this code. If it's Victor who pushed a code, if a line of code that made the whole system fail, it's easy to bear responsibility and say, Victor, you did this. You own up, build again, or correct, or just own up. Unlike the previous, you had to go and again look one by one side, call him out and say, "Oh, who did this? Who did this?" Of course, I'm not going to admit it. Yeah. And then promotes trunk-based development. Yeah, trunk-based is a trick. Is an analogy. Top to bottom. Okay, top to bottom. There's effective communication. Then there's predictable low-risk releases. Yes. At least for this, you can share because you are interacting in real time. You can share feedback and then say, "Oof, I didn't like the bug." So you know, or if you pushed something, an interface that you are sure, if it looks something like, say, let's just, if you're seeing my Edge screen right now, I'm using Edge right now. So if you're seeing Edge and you're saying this bookmarks part, this copilot chat, why is it here? Could it have gone, say, below the edge? I don't like it here. It's distracting. So you see, you could predict something like that. You could talk to your team. So the part about feedback communication, it's easier now. Yeah, and that's it about benefits. And the benefits you can notice again, notice the principles, the goals, you'll notice they're just aligned, like they're just together. So if technically if we didn't talk about the goals, if we didn't talk about the benefits, you could just come up with them from the principles, right? Yeah. So the tools. Now let's go down to our tools. Now for our source control, you know it. It's source control, version control. It's basically where you share your code, you merge your code. Now we have GitHub, Bitbucket, GitLab. It's few people that use Bitbucket and GitLab, but I've interacted with teams that are using it. I usually wonder about the preference. I don't know why I will switch, but to each their own, right? I don't wonder. But I've seen people use for GitLab. It's almost similar to Git. It's similar. This the interface. It's similar. So it's easier to use. But I've seen people prefer to push their code to Bitbucket and GitLab rather than GitHub. I don't get it, but anyway. Then we have the CI servers, the build tools now, the continuous integration part where the build happens. We have Jenkins, we have Circle CI, Travis CI, Team City. The preferred one here is Travis CI. Yeah. And by the way, if you're a student, just go to your GitHub student developer pack and get a free Travis CI pack for the whole year. That you can just start building right now stuff. Yeah, by the way, they usually give out Travis CI as part of the student developer pack. Just have all you have to do is share your school email. That's it, and prove that you're a student. That's it. So you can get a free Travis CI. Then the next year you are still in school, you renew it. But who knows? The next year you could be hired, so you could be paying for yourself. Yeah. So Travis CI is the most used. I say from the interactions I have, Travis CI is the most used one. Then we have followed by Jenkins. Then we have the Circle CI. Circle CI and Travis CI look similar. There's a bit of change in buttons, but they look similar. So this is how. Let me just show you how Travis CI looks like. This is it. This is what the one I was building here. It's Travis. It's my go-to favorite myself. So Travis CI. This you can look at the dashboard. So it's easier. It just lists your active repository that way. This way, all of them. Okay, these ones, yeah. So these are the new repos that you can't notice, but for the old repos, and again for the builds you have, yeah. So yeah, again, yeah. See, this one's it. This one, yeah. I have had some fails. You can see, yeah. This is what I was doing. These are the good runs. Then I've had some fails too. So for me, like, for again, I'm from the ML perspective, so I could be working on uh the model part, deploying the model part. That's what I could be called in for. Or sometimes because I interact with software engineers, so there are some things I might pick up, the small things. So they may say, "Oh, Victor, come help us here," stuff. But I don't focus on software engineering. But I know if you focus on software engineering, you could have so many repository here and the build part. Yeah. So yeah, that's how it looks like. You can you link your GitHub. That's it. Your repository are linked directly. Then you can link the payment method. But that's how Travis looks like. Oh, sure. Then for our deployment tools, now we have AWS Code Deploy. Yeah, AWS Code. AWS. It's basically just part of AWS integration. I want to show you because just like that, to I've linked my AWS to the I've linked my AWS to what is it? Yeah, to Jenkins, and the payment's the same. So if I trigger one, I'm afraid if I trigger one build, that's it. Yeah. So sorry about that. I don't know why that failed. Yeah. So AWS Code Deploy is part of AWS. There's Octopus Deploy and Spinnaker. Again, Octopus Deploy and Spinnaker, they're not heavy. So deployment tools again, they're part of cloud. So you have there's this common one I've seen people use. Selenium. Okay, Microsoft Azure. There is GCP. They have theirs, but for the teams, and the most times I find people have a preference that it's AWS that was meant for software engineering for some reason. Till date, I don't know, but it's like a lot. interact. When I'm interacting with teams, I'm told set up on AWS, not on Azure, on GCP. But of course, they have GCP and there's AWS. There is this, oh, DigitalOcean. Yes, DigitalOcean. I should have added DigitalOcean here. Yes, DigitalOcean is a very great example, and it's free. Also, DigitalOcean, if you're here and you're a student, you can get it from the developer pack for free for a year. Then we have container tools. Container tools, we have the Kubernetes, then we have Docker, then we have AWS ECS, AWS Elastic Cloud Service. Elastic Cloud Service. So AWS ECS again. So you see, AWS Cloud has made it easier. All these tools are there. This Kubernetes there. There is Docker there. But for the purpose of here, let me show you how Docker is set. It looks like. Yeah, show you Docker real quick. Just log in. Okay. No, it keeps signing me out. Okay. So it's set up. Yeah, that's it. That's it. So you can see. So these are my builds now. Yes, yeah, these are my builds. You can see the engine. You set up an engine. I mostly use Ubuntu. The image, that's the default. That is. But you can change it and change. I've seen people use Alpine. I can see people use. There's these versions of Linux. I'm just forgetting them, but people use them. So again, it just has sets you up repositories, and then you just develop it from there. So you can see. So these are images. So the Redis, this is a database. The Mongo Express, another databases. Yeah, and these are the app images, the front end, the back end, the user. We don't want exact speak with the user was, but this was the network, the reverse proxy. Then this was just a test. This was a test. So you can see the number of downloads it has made, the number of the builds itself. So they're inactive because it depends again on the CI pipeline to to build, and it's public. So it works like repository. You can just click here, the Redis. See, it's an engine. Yeah. And then the great thing, the Docker Hub has made it easier. The build part is very easier now with Docker Hub. They have given you a very easier. So you can see how it looks like. So yeah, that's how it looks like. Then you can set up collaboration. Then there's something about, never mind, never mind. Yeah, you can set up collaborators. Then you can interact with your Docker and your machine. Yeah. So that's how Docker engine. Again, I'm showing Docker because Docker as a container is the most used. Then Kubernetes, of course, Kubernetes. But most cases, you'll find you interact, you connect Docker and Kubernetes. But if you have a cloud service, AWS, that's easy. Just create a bucket, then the bucket will link you with Kubernetes and Docker at the same time. But for the ease of this, because it's the fundamentals, just know Docker and Kubernetes. Because AWS is its own class. The setup again, it's its own world again. Yeah. So yeah, that's it. Now let's look at best practices. Of course, it's like any field in technology. You don't doesn't want you to dive in face first. You might fall. Okay, you have the best practices that need you to use. So here's a summary of the best practices. And then these best practices, like I mentioned, it's from how I've learned, from the times I've interacted with teams, the times I've built myself, shipped myself. This is the best practices I find. So we have in testing, the testing part, we can always automated testing across units, integration, UI performance. Yes, automated across every. Don't always assume like, oh, I trust my UI. This is perfect. I don't need a test for it. Okay, just assume anything. Just assume anything might go bad and build tests automated across everything. Okay, just build test. Don't assume I like my UI. I feel like it's great. I don't see the need for building a test. I don't see the need. Just build. Then data management, you can set up part of it. This is deeper part. Now the shifting test left was mentioning, and remember, we mentioned each other under the principles. Yes. uh, so this is the testing part earlier, the shift. I want just to remind you, you can see how I try to interlink this stuff so that it's easier. Once you look at the doc later, you'll find it's easier to come back. So the shifting testing left, so as I mentioned, it's the prototype before, it's the after prototype part, the immediate after prototype. So it's recommended that, always recommended, after you've written the prototype on paper, work on it first, or work on it internally before you assume, before you start the project itself. Just work on it, then brainstorm with yourself. Okay, so that you can be sure where we're building from here. The shifting test left part. Then for the infrastructure, uh, employ the infrastructure as code techniques. The Docker. Always just assume, always just employ them as infrastructure. Infrastructure as code basically means you are using your platforms as code platforms. Okay, they're necessarily your engines, and they are platforms. So you are advised to use this infrastructure as code. That's why I'm saying. That's what I'm saying. Let's say AWS, right? I'm not saying don't use it, but for fast, please use Docker. That's way you build from the ground up. That's another way from looking at infrastructure as code. So all these CICD, these tools we have, they're run as infrastructure as code, but how you use them defines the infrastructure as code setup. Then you have the consistent development, test, production environments. Yeah, the consistency so consistency is one thing that I find it's everywhere. The consistency, it's needed everywhere, not in development, not in what other part, in life itself. So the consistency in the development, the testing, the production should be every time. That's a best practice. Then automated provision of services, automation provision of network. You can see, let me show you something here. Automated provisioning as an example. Yeah, we have our reverse proxy. Reverse proxy was our network. Think of this as a network. It was to enable all this, the app, the front end, the back end, to communicate. So it's the network. So automated provisioning, you can think of this as our automated provision. Let's look at an example for the container part. It had an image pull policy, always pull, at all times, always refresh the image. That way you are provisioning your service all the times. You don't have this fail because this Docker reports to you that this image is old, there's a latest version. There is a policy that is always pulling. Okay, then there is the small stuff. Let me look at replica. It's one. You can set up two replicas. That's just small stuff, but it helps you so that you can understand this image. There's another replica of itself somewhere there in case the first one failed. So there's another replica somewhere that will come in front when the first one fails. So this reverse proxy is an example of provision. You want to ensure your system works every day, especially if you're deploying in cloud. You will want that. You will want provisioning 24/7. Set up well. You will set up. Let me see. US East One is the most common servers that we use. Where here in Kenya, that for example, and I think it's in EMEA in general. Yeah, I think in Nigeria also. Yeah, US East One. But what works for you best? If the servers in Australia West One that works for you, well and good. It's like VPN basically. If you choose a weak VPN, say choose a weak VPN that's very far from you, you'll find the services that you want are not even easily being rendered. Yeah. If you've noticed, if you've used it with VPN, think of it, that's analogy. Now the monitoring, we have the log, metric traces, and that's the beauty of the cloud. The cloud will give you these things. I know the cloud. Anyway, just let me not go far. Travis AI will give you the logs, will give you the metrics, traces. I just the logs, mostly the logs. But the cloud will give you this. Will give you this. You can set up. You can set up on your phone emails. You get emails when there's downtime. emails when there's a new build or emails for a new version, alerting on failures, dashboard for visibility. Yes, so AWS, that I've used it, it has a dashboard. Once you set up the ECS, there's a dashboard, that option that you can set up. Then everything is the monitoring part is enabled, not the culture part. Not the culture part, is the human part, this teams part. Because functional teams focus on small changes, of course. Yes, focus on small changes. It comes back to this point of consistency. Sorry, it comes back to this point of consistency, right? Yeah, focus on small changes. Don't ever assume that this is a small change. If you work in teams, you'll realize any small change, even if it's a one line, it's a mega change to the entire repository. Then blameless postmortems. That's the beauty of CICD. As I mentioned previously on the code bases, you are you couldn't know who did what. So, but for this, now you know. Now there's blameless. There's no need for blaming anything. There's no say, oh, it's a certain fellow from certain team B, from certain team A that pushed the change last night. Blah blah blah. No need for that. Okay, now that's as a best practice. Always ensure there's blamelessness. Cross teams. Yeah, that's it for best practices. Now, what next? Now you're thinking of where to start. For me, when I was starting, I think there was a Linux fundamentals by Linux Foundation that set me up. Yeah, I really liked the course. So start small, pilots here on one app or service. Yes, pilot small stuff. Could be it could be a web app, could be a flask. Yes, small stuff. Then prove value metrics, cycle time, deploys by day, lead time. Again, I'm using stuff that I was using when I was beginning, or stuff maybe that I felt I could have used with, for example, the metrics part. I felt like if I had known that earlier, but a good thing I learned it, so it's okay. But if I'd known earlier, the metrics part will come in handy. Then prioritize test automation. I've mentioned this, we've mentioned several. Prioritize always the unit and integration test first. Prioritize them first in your Travis here. Mention please. That's one beauty. If you prioritize, you'll notice the beauty in CICD easily. Then treat infrastructure as code. Yes, very well put. Treat every infrastructure as code. So, and as I was mentioning, say Docker. Okay, you don't treat it like it's a tool. You treat it as the infrastructure. It's code. It's a code base. So you deal with it when you deal with code base. If there is a setup you did on Docker, it needs to align with the setup you did on Travis CI. If the .yml files you set up on Docker Hub, they need to if they need to look out the same as the one on GitHub, so on and so forth. So that's treat infrastructure. So, and remember we mentioned infrastructure is everything. The CI/CD tools themselves, the Docker Hub, the Jenkins, all that. They are infrastructure as code. Then involve developers early. Yes, involve developers. The testing part. In the first version, you want to test with developers before you test with that's the internal part. Before you test with the external community, the users. Get buy-in to adopt CA practices. That's I highlighted it, but don't focus. Just involve developers fairly. So the buy-in is when you pay customers, the users, just for a study on the app. But that's an option. That's a big organization. Okay. You've interacted with this Android. There is this pay service that I was it paid. There is this startup that does payments. Yeah, it's in Nigeria and Kenya that I've used. So I was part of the buying to adopt CA practices. There was the team that was testing the app itself. So you see such stuff, but it's big organization. You have enough funding, you can do it well and good. Then address cultural obstacles, blameless culture. Ensure there's blame. You need to know who pushed this code. That's why there's Git version control. Then small incremental changes. Small back to our point here. Start small incremental changes. So that's my advice on getting started. Yes, that has been it. That has been my quick rundown of obviously quick, but that's quick overview of CICD, the fundamentals, and open to the questions. The floor is yours. Let me see if there's some on the chat.
So thank you so much, Victor. The presentation was awesome.
Yeah.
Yeah. So in case there is any question, you can raise your hand. So I can see Brian has a question. So just a second. I allow you to speak, Brian. So let me find you and allow you to speak. Just a second. Just a second, Brian. Sorry for the delay. I hope your question will not forget your question. Go ahead, Brian.
Hello, guys.
Hello.
Okay, so no, I just wanted to point out some few details. So when talking about this, okay, so about CI, uh, so when he was giving the difference, there was he was talking about there's the GitHub, you've got GitHub, GitLab, and uh, Bitbucket for code management, yes. But then there's for the CI, he was talking about Travis CI and Jenkins and all that. You see, the thing is, so previously, Kina GitHub and so they didn't really have CI embedded in them. But see, for the last few years, 2 or 3 years, they've integrated CI systems inside them. So currently, you'll find most of the teams won't really be having a detached CI system. You see, instead they'll be using their code management system as their CI. Because let's say GitLab has GitLab CI, GitHub has GitHub Actions, and then Bitbucket has Bitbucket pipelines. So I find that most of the teams nowadays will only be like they won't really the need for a detached CI system is really going away unless they have a number of their systems already using, like, let's say Jenkins or Travis CI or something of sort. But realize that for most of the new projects, they'll tend to use the CI systems that are already inbuilt. Though I'd say some of them are still new because, like, my company we use Bitbucket actually for work, and so Bitbucket, you realize maybe if you have some maybe complex build you wanted to make, maybe if it's that complex, maybe you might not find the feature there, but there'll be a plugin for it. So okay, there is a shift towards that, and also so maybe something I just wanted to let the people know. Maybe okay, I'm assuming some of the students are also in the meeting. So there's also there's a shift. So with the CI and CD coming in, there's a shift towards when packaging. See, previously what used to happen was that with your application, you will package your application either if it was going to to be deployed into maybe a Linux system, it will either be into a deb, or maybe you will package it, let's say it was a Java application, into WAR files or something of sort. But you see, that would bring in issues for the IT ops team, because now that means you'd have to set up servers, and the servers would have to have the different requirements for those different technologies. But then you see, now that will be difficult because now you'd have to set up, like, let's say there is this server for this, there's the other server for that. So you'd find a situation where the IT teams is managing like hundreds of servers, hundreds of different servers for different applications. You see, so to do away with that, now that's why the subject of containerization came in. Because with containerization, you're able to package your application into a container. And what is a container? So in a container, it's your application plus all of its dependencies, all of them are inside, are all bundled together. So you see, you're able to just ship this to anywhere, and as long as somebody runs this container, all the dependencies of the application and everything, all of that is bundled in. So I just wanted to at least let the guys know that. Thank you.
Thank you.
Yeah, yeah. Oh, thank you. So anyway, I don't. Yeah, for the GitHub Actions. Anyway, I don't know. We mentioned it. We mentioned it actually. So I was mentioning. I used the example that there was a conference that didn't require me to submit the paper, so I had to do it by GitHub. Then we noticed the actions. Anyway, but thank you. That was great. That great to point out on the containers part also. That was real great to point out.
Okay. Thank you. Thank you. So is there anyone else? Thank you, Brian. Anyone else with a question? You can just raise your hand or comment. It doesn't have to be a question. Yes, Brian.
Okay, I have another clarification on the ISA, infrastructure as code. So essentially, infrastructure as code, what it means is, you see, usually you've got to, like, let's say if you deploy application or something of sort, you've got to set up a server. Once you've set up a server, you've got to do some configurations on it, depending on what you'll be running on that server. And see, you'll do that today. Maybe tomorrow too, you need to set up a similar server and do other configurations in it. So essentially, okay, infrastructure as code implies that, you see, the process of setting up the server, like building the server, okay, spinning up a new server and maybe giving it the different configurations, like maybe once the server is up, do install this, install that, install this. So you see, doing that, now, you, rather than having somebody to do it manually every time, because of course usually you'll find there's somebody in the IT ops team or the DevOps team who's assigned to be doing that. So rather than somebody having to be doing that for, like, let's say an application of sort, you instead have you instead turn this into code. Like, let's say if you're using, let's say, Ansible, right? So you have your Ansible. So in your Ansible, you tell it how to, so it should spin up this server, and then you have configuration management on it. You write the configuration management for that server. So once this is pinned, it should install this and that. So with that, with the Ansible playbook, you know that if you run it, it should spin up a server, and it should, like, let's say, install the different things that needed to be installed, that need to be installed. So you see, you don't, so the person whoever's in charge doesn't have to manually do the installation or like run different configurations on the server, but instead it's done automatically. And let's say you're managing like 10 servers or even 100 servers, and you want to, maybe for compliance purposes, there's something that needs to be added, rather than having to go to the different servers to add that thing or maybe to change a thing. Instead, with your configuration management, let's say you're using Ansible playbooks, you know very well over there, like, you stored the configuration management for all your servers. So if you just change one, then you apply it, you know very well, these are, whatever you've applied is going to make this change into all your servers, and then maybe they'll be compliant, or maybe they'll have the new thing you need. So you see, the need for IAC is to avoid the need of having to manually set up your server and do the configuration and all that. So instead, code does it for you. So you spin up your code, it's able to set up your server, able to set up, like, let's say, the dependencies and all other configurations that are needed.
Okay, thank you. That is very true. So, is there anyone else with any other question or concern or any other addition? Anyone else? Okay, so if there is no other question, thank you, Victor, for the presentation. Thank you for your time, the time you took to prepare. And thank you for delivering it in a very simple way that people can understand. So for those who are new to DevOps, it's a good field. Be encouraged. I've just shared a video there on the chat that I did on getting started with DevOps. So in case you want to consider DevOps, you can watch that video on our YouTube channel. And I'm going to share this video as well on the YouTube channel. So you can just follow us on LinkedIn, Twitter, WhatsApp, and you're going to upload it. Once you upload, we are going to share the link as well. But you can also subscribe to our YouTube channel so that when we upload, you can be able to see the video. So for all the sessions that we have done, we've shared the videos on our YouTube channel. So if you are joining the community today, you can still be able to see what we did in the past. So you can be able to see what other speakers have done. And we are lucky to be a community that has been able to have a lot of experienced speakers that have been able to share their knowledge with our community members from all companies, including big tech. So you can find a lot of information there. And in case you are experienced and you would like to share your knowledge as well, you can reach out and we'll be able to slot a session for you. So for those who joined today, thank you for joining. And we have a number of events that are lined up. So we are planning campus tours, and this coming month we are going to KCA and TUC, and then we're also planning to go to Strathmore. So those are the universities that you're planning to go to. So we are going there to tell them about DevOps, as well as we are going there to mentor them as well, to see how we can be able to mentor them. And we look forward to impacting more people. So in case you're a campus student, you can reach out to your fellow students and inform them. In case you think you want us to come to your campus as well, you can reach out and we'll be able to plan that. So you can just reach out to me on LinkedIn. I'm Samuel Kadima, and then we'll plan that. So that is it for today. I wish you guys so yeah, so you can I don't prefer to share my number here. So maybe you can reach out on LinkedIn and then we can talk. I can share my number there. Is that okay, Brian? Yeah, so you can just look for Samuel Kadima on LinkedIn. So I wish you guys a good week and enjoy your night. See you.